we push g of x, so it's no longer f of x squared on 4a squared, so it's still a parabola. A is a positive value, therefore it's a positive parabola. And we've got a tangent to g at x equals negative b, where b is a positive value, so it has to be over here. Okay, nice diagram. The value of b and a in terms of the shaded region is a minimum. Find the value of a and b such that the shaded area is a minimum. Okay, so I'm going to repeat identically the same as what I did over here. So I'd like to find the tangent. So I'd like to find a normal to this at x equals negative b. So I'll grab my term, but on the bottom I will put 4a squared instead, and I'm going to use a. Press X here, make sure it's okay. Yes, it's okay. Then what I'd like to do with that is go interactive calculation, line, normal, and I'm going to put it at negative b. And that will give me the equation of the normal. And I'd like to take that, which is the equation of the normal, this line here, and I'd like to make it equal to the parabola and solve for x. And that will find the two x-intercepts, so the two intersection points. Now I know one of them will be minus b. Advanced solve for x, okay. And of course I got minus b, and I got this expression. So this coordinate here is 8a to the 4 on b plus b. So that I get a method mark, the area is going to equal the integral from minus b to 8a to the 4 on b plus b of the yt minus g of x dx. So that gives me my method mark. And I'm going to call this yt, and I know that yt is this expression here. Okay, so I will open up my integral. So integral, my lower terminal is minus b, my upper terminal is this in terms of a and b, my top curve is this straight line, so I'll copy it and then I'll paste it there, paste, and then I'm going to minus from all of that the bottom curve, which is my parabola, which is this, that there, and all of that with respect to x. And I get that awful expression, hit simplify, oh, much nicer. Oh, how good is that? Okay, the area equals 4a to the 4 plus b squared cubed on top of 3a squared b cubed, and that's what the area equals. So find the value that the shaded area is a minimum. So for the shaded area to be a minimum. Okay, so I've got this expression for area in terms of a and b. I could try f min, or I could take the derivative and set it equal to 0. On both occasions, if I was to graph, I'm finding the minimum value by using f min, or when the derivative is equal to 0. So the problem that I do have is I have a's and b's. If I was to do f min, so if I get an expression for the area, go back up here and find an expression for the area. There it is there. Copy, paste. If I was to go interactive, calculate f min, do I do A or do I do B? Since it's asking for my answer B in terms of A, so I'll do B. Variables B, and B can go from, it's got to be bigger than 0, it can't be equal 0, so 0.1 to infinity, and it just gave me the same expression. So the problem is I've got A's and B's, so I need to take the derivative. So I'll take the derivative with respect to B and then set it equal to 0. So math to derivative with respect to B, and I'm going to make that equal to 0 and then solve for B. and I get b equals negative something, well, b is positive. I can't take the square root of negative a to the power of 4. b equals minus 2a squared. No, this last one is the only one that makes sense. So b equals 2a squared is the value of b when area is a minimum. And it's a 4-mark question. So I think that I've got my expression for the area in terms of a's and b's and in terms of the actual integral, 4 marks. So I'd like to write y of t equals, and I'd like to write that derivative, that tangent out, just in case there's a mark associated with it, and there's my tangent there. So I've got 2a squared on bx, because that's the only bit that's got an x in it. So then plus 2a squared plus b squared on 4a squared is the tangent line. And that's question 1.